It's reached a stage now, I suppose, where we can say that they might be on the brink of moving towards what Albert Einstein classified as the unified theory of everything. Ever since his time and the days of Watson and Crick and the DNA discoveries 50 years ago, they've been looking for this theory. They don't know what it is. They just know that out there somewhere is a holy grail of physics. A holy grail, a theory that will tie everything together from the smallest, tiniest microcosm to the biggest of the macrocosm. And in this, there's a whole new language evolved. We've got things now called superstrings and quarks, superconductivity, all of these new terms, these new words. We have an awareness now of hitherto unknown planes of existence, realms that exist beyond our own three-dimensional space-time. In the field of quantum mechanics, scientists have recently confirmed that matter, any matter, can be in two places at the same time, two places at once. Quantum entanglement has enabled physicists and scientists to link particles now that are millions of light years apart. They can connect them to each other without any physical contact going on. Space-time can be manipulated now. Teleportation in the Star Trek fashion is becoming a reality. Gravity-resistant material is now being heralded and used in the early stages of new type of air transport. And all in all, virtual science is taking us into realms that just a few years ago we would never have believed possible, let alone in any way plausible in this short space of time. So we'll be looking at developments in these fields, and we'll be looking at a strange superconductive form of matter in particular. It's called an orbitally rearranged monatomic element. For those who aren't familiar with this substance, this orbitally rearranged monatomic element, it looks very, very ordinary. I have a sample here in this thing. You can see it probably. It's just a white powder. It just looks like French chalk, only it's finer, like talcum powder, but it's finer. Pure white powder. What is it? That, not so very long ago, was a sliver taken from a Canadian maple leaf 24-carat gold coin. It has become that. What is it? It's gold in a non-metallic state. It's gold in the state that it originally would be in particle nature before the metal-metal bonds get together and turn it into the yellow material, the substance that we know so well. In essence, the word monatomic, orbitally rearranged monatomic elements, monatomic is simply that, single atom, monoatomic. The powder is comprised of clusters of single atoms. It's called asymmetrically deformed high spin. It happens when the nucleus changes shape, when the electrons start moving in a different way, and the whole thing just falls apart and says, hey, I'm not gold anymore. I don't know what to be. I'm just going to sit around as a bunch of atoms. And that's what it does. But the weird thing about it is that the moment it's in that state, you can put it through any analysis or testing that you want. Nothing will ever tell you anymore that it's gold. It's not gold. It's the elements that make gold. Just like the flour and the eggs and everything else won't tell you that they're pastry until you put them together. Well, anyway, the astonishing thing about all this is that this monatomic powder of high-spin gold is not actually a new discovery. The ancient Mesopotamians knew about it, they wrote about it, they called it Shemana. The Egyptians described it as Mufkut, and the Alexandrians venerated it as the Paradise Stone. At all stages of its history and whatever culture, it was called in one way or another the powder of projection. It was reckoned to have extraordinary powers of levitation, transmutation and teleportation. Many old texts talk about it having these properties, but it was simply the powder of projection. It was said to produce brilliant light. Yes, it does. It was said to produce deadly rays. Yes, it does. It was said at the same time to be an active key to physical longevity. Yes, that's what it's looking like it will be. In today's world, have described these materials as exotic matter. Exotic matter. It's the first time a nondescript word like that has come into the scientific fraternity. Exotic matter. Superconductivity, one of its primary characteristics, is now claimed by the Center of Advanced Study in Illinois as being the most remarkable physical property in the universe. So these are big words, strong terms to use about something that's just an ordinary looking white powder. It's clear from the documentary evidence of ancient times that the attributes of superconductors, gravity defiance, these sort of things were known, even if they weren't understood, in that distant world of priestly levitation and communication with the gods and the phenomenal power of what the Greeks called the electricus. The Golden Fleece legend centered on the quest for the secret of this substance. They were looking for this mysterious paradise stone of the Alexandrians, this golden fleece, this vellum with the secret written on it. Well, given that mysterious processes concerning gold have an alchemical ring about them, it's interesting to look at some alchemical writings from the past. Alchemy, the Alexandrians called it the paradise stone, it's called the powder of projection. Well, there was also, along with the paradise stone, there was the philosopher's stone, and that came up in many old texts as well. So we can look at what was said about the philosopher's stone, forgetting Harry Potter and what they made of it. We can look first of all at a fellow called Irenaeus Philalathus. Philalathus was a very, very notable 17th century character. He was around at the time that Charles II implemented chartered the Royal Society in 1662. He was there as a background advisor through a long period of time to people like Robert Boyle, Edmund Halley, Christopher Wren, Isaac Newton, these sort of characters. All of the new sciences that stemmed from that new society back in that period had people like Philalathus at the back of them. He was revered by all of these people. Elias Ashmole of the Ashmolean Museum, these sort of characters. But Philalathus was a chemist, an alchemist of his time, and he decided in 1667 that he was getting a little bit fed up with the way that the church and other organizations were sort of mocking chemistry and alchemy in those times. The Royal Society was now on its way up as a classified institution, and he thought that alchemy and these new sciences should come together. So he decided to write in real terms what, according to alchemical structures of the day, the philosopher's stone was. He produced a work called Secrets Revealed, published in Amsterdam and subsequently translated into English and other languages. From Latin, he wrote it in originally. Anyway, he discussed the philosopher's stone, and what he said was this: our stone is nothing but gold. It is gold digested to the highest degree of purity and subtle fixation. It's called a stone by virtue of its fixed nature. It resists the action of fire as successfully as a stone. In species, it is gold. It's more pure than the purest, but its appearance is that of a very fine white powder. Sometime earlier in the 15th century, we can go back 2 centuries before that, to Nicholas Flamel, probably the best known of all the early chemists, the man who started in France with nothing, spent 20 years studying his subject, and then became one of the greatest benefactors that France has ever known. Buildings all over the place granted from him, and nobody quite knows how he came upon his great wealth, but he did. Anyway, he wrote in his last testament written in 1416, November 1416, and what he said, and this is a couple of hundred years before Philalathus: when our noble metal is perfectly prepared, it makes a fine powder from the gold, and it is this which is the philosopher's stone. So same thing again. They're talking about preparation, digesting it, all of those things, but in one way or another, by some means, and in fact we've replicated some of these means now, and they're beginning to work. Now we understand some of the terminology in modern scientific terms. So the philosopher's stone was the powder. It was the paradise stone of the Alexandrians, the same thing. It was only called a stone because it wouldn't burn. Just like stone, it was resistant to fire totally. We can look back to the Egyptian pyramid text. We can go back quite a long way, really. We can see references there to a mysterious substance called mufkut. Now, mufkut appears in many hieroglyphs, many guises, many reliefs in various parts of Egypt, and it's always associated with the same thing: an ethereal location, an other world of some sort, the realm of the blessed. They called it the field of the mufkut, the field of eternal gold. Mufkut was described in Egyptian terms as its powder of projection, so Egypt called the powder of projection mufkut. There's a bas-relief of Thutmosis III at the Temple of Karnak, a very intriguing picture there in the stone, which shows the treasures of the pharaoh. And they're all laid out in shells, and it shows all of the wonderful, valuable things that he has. And there's silver, and there's metals, there's gemstones, there's all the things one would expect to find in a treasure trove. But there among them, in the metal section, are these little conical devices sitting there on the shelf like little upturned ice cream cones. These are the things labelled as mufkut. It says, and it explains underneath, that they're made of gold, but it further explains that we call them bread. They're made of gold, but we call them bread. And that's quite interesting, because we discover in various other texts and reliefs that this powder was in fact made into bread cakes, or to little cakes, which they used to feed to the pharaohs. They used to eat it, the stuff. It was at Karnak, where in about 1450 BC, thereabouts, Thutmosis founded a priestly brotherhood at the temple, a high council. 39 men and women sat on this high council. They were called master craftsmen, and the people around, the Alexandrians, when they wrote about them, called them the Great White Brotherhood. Why were they called that? The Alexandrians explained, because they were obsessed with the mysterious white powder of projection. That's what they used to do in the temples, and we've discovered this now. Most of the temples of that period were either set up for or had within them facilities for manufacturing this product. The word worship associated with temple is interesting. It doesn't appear in the English language until about the 8th century. Prior to that, it had a K in the middle of it. The word was workship. It was always workship. People didn't go to the temples to venerate the gods. The priests were there to work for the gods. They were workshops. So it's quite interesting. It ties in with alchemy quite well, that. It features again in a mysterious Alexandrian document. There's a story about Alexander the Great going to the kingdom of paradise, the kingdom of Ahura Mazda, the Persian god of light, and it talks about his travels and how it was all made possible by the enchanted paradise stone. Paradise stone, it said, had numerous magical properties. Same thing, it's called the powder of projection, but it's the paradise stone. And this is a key thing, and this is what has been suddenly looked at and discovered in recent times. It doesn't make much sense when you hear it first off, but what it says is that the powder of the paradise stone will outweigh its original quantity of gold, but a feather can tip the scales against it. So it's heavier than the gold that it comes from, but it's lighter than a feather. A strange anomaly which has hung around for centuries, and it's not until very, very recent years that it's been worked out what that means, and we'll come to that just very shortly. Flinders Petrie, the great British archaeologist, discovered the powder again. He discovered mufkut again in 1904. Intriguingly so. He was researching the mountain wilderness of Sinai for the Egypt Exploration Fund. He'd gone out there to map the Sinai area that sits in the Gulf above the Red Sea between Egypt and Palestine. This is the land that Moses and the Israelites trekked across when they came out of Egypt and were on their way to the Promised Land. But anyway, he's there in this place. They decide that they're going to look for the mountain of Moses while they're there mapping this place. They follow the absolute directions that are given in the Bible, and they come to this mountain and they think, well, hey, this must be the place. This must be the mountain of Moses. What's it called? It's Mount Horeb or whatever. It's called Serebit El Kadim, the prominence of the Kadim. So they thought, well, okay, well, let's climb it. They climbed the mountain. That's what you do when you get to mountains. You climb them. So they climbed this mountain in the middle of nowhere, in the Sinai Desert, hundreds of miles from Egypt one side and Palestine the other. Wind-swept, storm-torn desert country. 2,500 feet above ground, on a plateau, unbeknown to anybody, they found an Egyptian temple. 270 feet long outside, and a large amount of the temple running inside the mountain. It seems that they carved out the cave to build the outside structure, so it had two aspects to it, inside and outside. The Bedouin didn't know it was there, nobody knew it was there. They decided this was probably the biggest biblical discovery ever made. It had reliefs, engravings, carvings, all sorts of stuff going back such a long time, right back to 3rd, 4th dynasty Egypt. We're looking at about 2.5 to 3,000 BC. Every pharaoh through the Egyptian dynasties, right up until the time of Akhenaten, every pharaoh had a relief there, had a standing stone there, had written something there. The whole history of Egypt was told in this temple, and yet what Petrie wrote in his report was that it seemed to him more like a chemist's workshop than it did like a church. There were bowls and crucibles and furnaces and all sorts of things there. In fact, all the sorts of things that the Bible seems like it might be describing. There was fire on the mountain, it said. The mountain quaked as if there was a furnace. Well, actually, yes, there was. It's exactly what there was there, a furnace. What the heck were they doing? Well, they found it hidden beneath flagstones. A beautifully, wonderfully stored and protected hoard of pure, white, unadulterated, fine powder. They didn't know what it was. They winnowed it, they sieved it, they did everything they could. They had no idea what it was, and in fact, in 1904, there's no way that anybody would have known where it was. They brought some back to this country. Petrie was actually told that that was the last time he would be funded by the Egypt Exploration Fund. He got no more money from them. He was our prized archaeologist, and that was his life done for. He had to get money from abroad from then on. He had broken the rule. The rule was, on the first page of the Memorandum and Articles of Association of the Fund, it said, we will grant money for digs and excavations to make discoveries to uphold the teachings of the Old Testament. Well, what he said he found was the greatest biblical discovery ever made. What they said was it doesn't uphold the teachings. What he said was, yep, but it upholds everything that's written there in the book of Exodus. And they said, yes, but it doesn't uphold the teachings. There was a difference pointed out to him very strongly between what was written and what was conventionally taught. There still is. The place was called the House of Gold. This whole complex was called the House of Gold. There were reliefs, representations all around. Some are still there. Others have been hoarded off, carted off into museum storage. They show the pharaohs in turn, or the gods maybe, being presented with these conical cakes. They're called mufkut. They're called the giver of life. All of the things that we know are now applicable to this monatomic substance. The man in all of the reliefs who presents them is called the treasurer over the House of Gold, the one who gives the precious stone to His Majesty. And this went on through dynasty after dynasty after dynasty. It was said to be the means by which the pharaohs communicated with the gods. It was said to be the means by which they moved and transcended into the afterlife, and all sorts of things. But above all that, it was reckoned to give them kingly qualities. Qualities of awareness, perception, intuition, all of those things that one would require to be a leader, maybe a cut above the norm. Well, we now know that it will do exactly that. There's an interesting bit in the book of Exodus, which I suppose we've all been taught, or we know of in some way or another, and it doesn't actually make any sense. Moses and the golden calf. Moses, we're told, goes up this mountain and talks to God, and comes down with the tables of testimony, 10 commandments or whatever, and breaks them when he gets back down, because he's terribly annoyed to find that his brother Aaron has collected all the earrings from the Israelites, all the golden earrings, and melted them down and made a golden calf for them to worship. Well, that's okay, that makes sense. Aaron's made this calf, and they're worshipping it. Moses says, no more, we have this new God now, we're not doing that worshipping idols anymore. So he gets very angry, and this follows. He took the golden calf, he burnt it with fire, he transposed it into powder, mixed it with water, and fed it to the Israelites. Okay, think it through. Burnt it with fire, turned it into powder. How do you do that? You burn gold with fire, if you heat it in any way, you only get molten gold. You might get nasty black sticky stuff if you go too mad at it, but you don't get powder. And even if you did, why would you mix it with water and feed it to the Israelites? Funny story. I remember being told when I asked the question a long, long time ago that I would understand it one day. Well, I think probably now I do, because it's beginning to make a lot of sense. Yes, of course you can burn gold with fire. Of course you can transpose it into powder. And we now know why it would have been mixed with water and fed to the Israelites. Probably not to the Israelites in general, but certainly to the priestly fraternity. And it was there that the new priesthood was set up. It was called bread of the presence. Bread of the presence of what isn't explained, probably bread of the presence of God or something like that, but it was the bread of the presence. Well, all of this story is all mixed and mingled with fires on the mountain and the burning bush that wasn't consumed. That's another interesting feature. The bush was aflame and it wasn't consumed. Come back to that in a moment. These stories are replicated further back in time in Old Babylonia, in ancient Mesopotamia. They called it Shemana, not Mufkut, but it had the same qualities. It was said to do the same things. It was a power generator of all types. The stories are mixed and mingled with the tale of the Ark of the Covenant, which in itself was a pretty magical device. It was said to levitate and to give off bolts of lightning and emitted rays that destroyed the people of 5 Philistine cities. It brought down the walls of Jericho. I mean, this thing was a weapon of mass destruction by the look of it. And it's all linked up with the stories of this bread of the presence, and seemingly always to do with gold. The ark itself was made of gold. We have these images of these 4 priests or whatever carrying it on poles. I went through the dimensions and the manufacture of the Ark of the Covenant with the World Gold Council. It's written in the Bible twice. It explains how to do it, and then it explains how they did it. Every measurement is given. Every piece of material is laid down. It's plated inside and out with gold. The lid is of pure gold. Well, that interested me. If this box, 4 feet by 2 feet roughly, has a lid on top of it with 2 cherubim, angels, or whatever they were on top of that, it's got to be a pretty thick lid not to sag into this box, because gold is soft. So I said to the World Gold Council, work out for me, please, how thick this lid would have to be to span this top. Well, they did, and they came back with the answer, and I said, what would that weigh? The lid alone, about 1.5 tons. What would it be worth? Something in excess of £10.5 million, today's value. So they've got this box, and it's quite impossible for 4 priests to carry it. But we look further into the text, and what we find is that it was said that the ark never was less than 3 fingers above the ground. It was always in a state of levitation. So, yeah, that makes sense. You can guide it. Is that possible? Yes, it's entirely possible. Okay, they're ingesting this stuff. Certainly we know from about 2,500 BC. That's about the earliest the documentation talks about it. Probably it goes back further in time than that, but we don't have any writing. The Egyptians said that this was to feed the light body, the ka. They called it the ka, the light body. If you feed your physical body to nurture it so that it will grow, you must do the same to the light body, it was said. This is the food of the ka. This is the food of the light body. The powder of gold, the mufkut, is the food of light. Okay, well, holding this in mind, we can move forward now to modern times. We can look at how, quite by chance, and really it was by chance, this all came to light again. How it was that suddenly texts such as "it weighs more than its gold, but a feather is heavier than it," and all of that sort of stuff began to make sense. Happened in America, it happened in 1976, and it happened in Arizona, Phoenix. Amazingly, Phoenix, it's actually ancient Greco-Phoenician for red gold, the word. It's interesting. Phoenix rises from the ashes. That's exactly where it should have been rediscovered, and it was. David Hudson, he's a 3rd-generation cotton farmer. His father was Commissioner of Agriculture for the state of Arizona. They've been farming about 70,000 acres in the Yuma Valley for 3 generations. They farmed cotton. Well, David explained that a natural difficulty in the area was that the soil wasn't really that good. The cotton produced was quite remarkable, but the soil had no topsoil to it. It was just dirt. They called themselves dirt farmers. It was eroded rock. That's all it was. But something in it was actually making it very difficult, and always had. They had to farm in rotation on a 3-year cycle. there was a very strange, nasty, black, crunchy stuff that used to rise to the surface. And they had to get rid of this. Well, the way that they'd been getting rid of it during David's lifetime was that fortunately, just down the way in the next town, there was a manufacturing plant, a product of which was pure sulfuric acid. So they're bringing in this sulfuric acid, and they're dumping this at 30 tons per acre onto this farm ground to begin to prepare that land for 2 years' time. They would follow it up with irrigation trucks. The water would then make the acid froth and foam and bubble and spit, and they'd put in some calcium carbonate to buffer the pH levels and keep the acid-alkaline balance correct. Anyway, they've been doing that for a lot of years, and David thought, well, it's very fine and well doing this, but why don't we just try and find out what's causing the problem in the first place? Instead of just dealing with the problem, let's diagnose it. So they decided to do exactly that, and they started testing the ground samples. Well, there was one particular material. When they took the ground samples into the lab and they put it through various filtration processes, they used chemicals, they precipitated it all out of this nasty black stuff, and what they were left with was this strange white grey substance. They didn't know what it was, but they were left with it in this base of this precipitate in filter funnels, and they just put it out in the Arizona sunshine to dry. That was the normal process for this lab. That's what they used to do, put it out in the sun on the wall and it would just dry. Every time they did it with this stuff, it exploded and disappeared. Just completely and utterly disappeared. They said it was like 10,000 flashbulbs. It was that bright. But there was no sign of it afterwards. It had gone. What was it? Was it an explosion? Was it an implosion? How would they discover? So what they did, they took a new pencil, unsharpened at each end, and just stood this pencil upright in the sample. Put it out in the Arizona sun, disappeared. Amazing great blast, and the pencil is still there. No blast. Wow, no blast? Just white light. White light. The pencil looked like it was being totally consumed by fire, and there it was, unharmed. Just like Moses in the burning bush. The bush was ablaze before his eyes, and yet it wasn't destroyed by the fire. Very, very similar. So they figured, well, we've got to find out what this is. They dried it inside, that was okay. It was the sun that seemed to be having the nasty effect on it. Well, at Cornell University, they had this amazing equipment. The equipment said, researchers said, look, well, we can analyze anything you've got down to 3 to 5 parts per billion. We can tell you down to 3 to 5 parts per billion what's in anything you bring us. And they said, we don't want to know parts per billion, we just want to know what this is. 100%, what is it? What is this stuff? Anyway, they analysed it on this amazing equipment, and they came back and they said it's nothing. Nothing? It's nothing. The machine doesn't read it, doesn't recognise it at all. It just looks at it and nothing moves. It's nothing. Okay, so it's nothing. What do we do now? We send it for arc emission spectroscopy. That's interesting. Arc emission spectroscopy, fairly standard in labs. You have a carbon electrode with a little cup in the top. You put the sample in the cup, you bring another electrode down on top, you strike an arc about sun surface temperature, it sort of hits it at about 6,000 degrees, something like that. And what it does, it burns off the constituents in accordance with their boiling temperatures and tells you what they are. So if, for example, let's say you were putting a motor car engine with its water into this equipment, it would tell you, first of all, that it was water. It wouldn't tell you it was metal, it would tell you it was water until the water had all boiled away. Then it would tell you it was metal and what metal it was. So that's the way it works. So they put this in the machine. They strike the arc burns for 15 seconds, and it tells them it's a very unique form of silica. It's a sort of silica. It has a bit of iron and a bit of aluminium in it. That's what it is. Well, that wasn't much good. It didn't tell them anything. They knew it wasn't that, because silica or iron, aluminium, whatever, they don't blaze into light and disappear. They just don't do that. They decided then that they were told that they ought to send it over to England, so it came over here, the sample. And It went to Harwell Laboratories in Oxfordshire, the government labs. They had neutron activation analysis. They didn't even care what the atom structure was. They could tell you what the nucleus was. So when it came here, test was made, report went back. It's nothing, pure nothing. They said, well, it must be something. We can hold it in our hand. We can pick it up, put it down. We can do things with it. It's something. And they said, yeah, but it's not in the periodic table. It's not anything that anything recognizes. It's something different to anything that we know. So it's nothing. Just don't worry about it. Anyway, then the Russians came on the scene and they said, look, we've been telling you guys for years in the West, you haven't a clue when it comes to analysis. You use these systems which never allow things to materialize for what they actually are. You use carbon electrodes that burn away after 15 seconds. So because the carbon electrodes burn away then, which is the boiling point of the carbon, anything with a higher boiling point than carbon can never be tested. And we said, yeah, but there is nothing with a higher boiling point than carbon. They said, oh, yes, there is. Plenty of things. So anyway, they had this new equipment built to Russian specification, put it through that, and lo and behold, it all began to happen, just as the Russians said. After 15 seconds, these little bits of impurity had gone. They amounted actually to less than 1%, this bit of silica that was in there. 99% of the sample is still there and it's burning away, and this thing is still going. They've now got it shielded in helium and argon, inert gases that keep the oxygen away and prevent the carbon electrodes from burning. And it's buzzing away. And anyway, 15 seconds, these things disappear. And then nothing. It's registering nothing. It's sitting there and it's nothing. 20 seconds, 30, 40, 50 seconds, 60, and it keeps going on and it's nothing and it's nothing. But our machinery in the West, America and Britain, never got that far. Anyway, at 70 seconds, it suddenly registered as palladium. Now, palladium is one of the 6 platinum group metals. It had actually reached the boiling temperature, not of the palladium metal, but of the palladium element. Following that, it kept going on. From palladium came ruthenium, came rhodium, came iridium, came platinum, came osmium at 220 seconds. And this machine was going to burn it for 300 seconds, right up to 5 minutes, as against 15 seconds. This material was 100% platinum and gold group elements. Nothing else. It wasn't nothing. It was these elements. That's interesting, said the scientists. We thought that everything that we couldn't get beyond was carbon. We thought that actually carbon was at the root of all life. We thought that carbon was, hey, maybe we should do some more tests. Maybe we should test some of the carbon in our bodies, because we think that that's what we are, carbon, life form. Well, anyway, they tested some brain tissue. You'll be interested to hear that the 5% by dry matter weight that you think, or we're all told we have in our brain of carbon isn't carbon at all. It's these monatomic elements. Most life forces, it seems, are composed not of carbon, but of monatomic elements of platinum and gold. We've never been able to test them. It took until the middle 1980s before we could do these tests in the West. Prior to that, we weren't really talking to the Russians anyway, so they weren't going to let us have their secrets. 1990 came, we had perestroika and all of that, and suddenly we're all in business, and it's open season. But before that, they were laughing at our medieval analysis techniques. Anyway, at that time, General Electric were looking at fuel cells, new fuel cells, and they were using rhodium and iridium. And they knew, the team knew that these fuel cells worked with straightforward rhodium and iridium, so they said, okay, the way to prove that this stuff really is rhodium and iridium, among other things, would be to test it in General Electric's fuel cells. If they work with it, then, yep, that's what we've got. We've got exactly what the analysis said. So they took it to General Electric, and they said, yes, it works. Everything works fine. This is rhodium, and it is iridium. These are platinum metals that you have here. They are simply in a form that science didn't know about before now. We, they said, have got kind of close to it. We've been looking at this stuff, but they said we've never managed to achieve it because, you know, they said every time we get to a certain part in our manufacture of this stuff, it all disappears in a great blaze of white light. So it goes somewhere. And the team said, yeah, that's exactly what it is. And they managed to put General Electric on track. So it was decided from then on that instead of using straightforward rhodium and iridium, that this stuff was better. It would hold more energy, it would attract more energy, and it would distribute energy more regularly. So anyway, they thought, well, we had to continue the test, because at that time General Electric said, look, you've got to put patent applications in for this stuff. Not that you've necessarily made it, the procedure isn't yours, but it's your material. It comes from your land. You have to have the material to patent, because if we're going to buy this stuff from you, we need to know that nobody else is going to be able to get in the middle of this. So anyway, the government said, well, look, if you're going to do that, there are certain things you have to do within the patent application. You have to tell us what it weighs per whatever denomination. There's a machine, they said, which will alter the temperature. It's called a thermogravimetric analyzer. This will lift the temperature up and down, and you can tell us what the mean weight of it is, because sometimes things can vary a little in weight if they're hotter or colder. So they put this stuff on the machine. Couldn't believe what they began to see. It wasn't just varying a little bit, it was varying a lot. I mean, tremendously. These graphs were going up and down. I mean, really, really big. The colder they made it, the heavier it got. The hotter they made it, the lighter it got. They actually got it to weigh something close to 700 times what it had started as. They got it to weigh less than zero. Less than nothing. Even the pan that it was in weighed more when the stuff was tipped out of it than it did when it was in it. Even the pan was levitating with this material. Think of the Alexandrian story. It will outweigh its quantity of gold, but even a feather will tip the scales against it. It's absolutely true what was happening. It could be so heavy, it was unbelievable, and yet it was not only levitating, but taking other stuff with it. Anything that it was on, it would take it with it. Now, it's quite remarkable how even small temperature changes will affect this stuff. I've had this little vial of mine sitting on some ordinary post office scales on my desk, the sort of thing that you weigh the mail on. They weigh a few grams, a few ounces. And I've just had it sitting on there, and without the room necessarily seeming to change in temperature, room temperature changes because of general vibrations and frequencies. It depends what the mood of the room is. If there's an argument going on, if there's something, on the radio that may be aggressive, or if the room's calm or whatever. This stuff changes weight in accordance with everything that's going on in the room. It will get lighter, it will get heavier. As the vibrations change, the friction changes, its temperature changes, and it gets lighter or heavier. Strange, strange stuff. Well, there was one particular point in this where the weight change was very sudden, very dramatic. Although it was gradually getting lighter and lighter, there was one point, and this was the point at which this white substance suddenly became the powder. At that moment, it immediately weighed only 56% of what it had weighed just before. So 44% of its weight disappeared in a flash, and that's when it falls to powder. Now, where did it go? Where did this 44% go? How can weight simply disappear? Because all they saw happening at that point in time was another flash of light. Does light have weight? No, light doesn't have weight. It illuminates space. It illuminates space-time. Maybe space-time has weight. Well, they discovered, yes, it does. If you can illuminate it, it exists. If it exists, it's matter. If it's matter, it has weight. It has mass. So then began the first experiments into manipulation of space-time. They decided that you could actually pick up space-time and move it around. Of course you could. Nobody ever said you couldn't. We just believed it was impossible. So they started on that. Well, we find then that all sorts of technologies start to root off of this stuff. All sorts of people begin to take an interest in what's going on. There are all sorts of corporations interested in anti-gravity. Where did the 44% go? What was very interesting about that was that there's a guy called Hal Puthoff. Now, he made the point in a paper that he wrote for American Scientists journal many years back. And what he said was that, he just made the point in it, that at a particular point of particle vibration, when a particle begins to resonate in a dimension that isn't our own dimension, it will immediately lose 4/9 of its weight. That was the same, 44%, 4/9, it was the same figure. But what he'd said was, when the particle begins to resonate in another dimension, interesting. So along goes David Hudson to meet with Hal Puthoff. And they discussed this, and what comes from it, and he said, look, if it begins to resonate in another dimension at that point, there must come a point, actually, when it totally moves into another dimension, at which point it will become invisible. And David said, well, yes, we've not had that happen on these particular tests, but when we put it out in the sun, it's done it. In the precipitate, it does exactly that. So anyway, they formulated a test procedure where they could take it more gradually to this stage, where they could take it beyond the 44% weight loss. Everything would begin to levitate. It was getting lighter and lighter and lighter, and they took it to the point where it just disappeared. And they said, yep, okay, we'll do it. That's proved that theory. It's invisible. And Puthoff said, maybe it's not invisible. What we're saying here is that when it begins to resonate like that, it's not resonating in this space-time. It's resonating in another dimension. How do we know that? What's the difference between that and invisible? Well, invisible simply means that you can't see it, but it's still there. What this was saying was it wasn't there. It wasn't there at all. Take the powder, this is the instruction, put it in the pan, have a nice little triangle, little cone of it in there, get it to the point where it disappears and know exactly where that is. Take a wooden spatula, and when it's disappeared, when it's not there, mess it up. It didn't come back messed up. It came back looking exactly like it was before it had disappeared. And they said, yeah, that's proved it. That stuff wasn't here in an invisible state. It was literally somewhere else. It had gone into another dimension, another realm. Again, precisely what the old text seemed to talk about, but nobody had any comprehension of what they meant. Can you bring it back? Yes, of course you can bring it back. The procedures at that time for bringing it back were very straightforward because it was done for a heating and cooling process, so they simply brought it back by bringing the temperature down again. But in fact, I mean, it's known now that the temperature is only a tool. What we're really looking at is frequency vibrations that the temperature sets up. So it can be done with frequency vibrations, it can be done with sound, it can be done with anything that sets up a harmonic within the structure of this, and you can move it in and out of these particular realms. So it tied in exactly with the Alexandrian text, it tied in exactly with the Egyptian text, it tied in exactly with what the Mesopotamians and the Babylonians had written about their stones, and it seemed to link in totally with the kind of culture that the Old Testament was talking about in the book of Exodus, the gold culture, using gold to make powders, having fires and furnaces on mountains. What was that all about? Well, they discovered what that was about. It literally was a furnace workshop on this mountain up there. They tested it for electricity. It wouldn't conduct electricity. They connected voltmeter to it with live electrodes. Nothing. It wasn't a conductor. In fact, it was a jolly good insulator. Well, that's no good, they thought. What's the point of that? What use is this stuff? What they discovered was that it was more than a conductor. It was a superconductor. What it needed to transmit energy, sound, or anything between itself and another likeness of itself was not something connecting it, was nothing, just simply a frequency. Like tuning a radio band, just getting the frequency right, and you can send anything from one to the next one. It's a superconductor. What do superconductors do? They levitate. How do they levitate? Superconductors have within them one controlling energy force, light. They run on light waves. They run on the light waves which we now know are exactly the same as the light waves that link our DNA structure. And the Egyptians used to call that structure the light body. We got to where the material was a superconductor. Superconductors are quite unique devices. The material isn't always superconductive. It has to be charged to become superconductive, but once it is, it will do all manner of strange things like its levitation and whatever. Superconductors repel any energy or magnetic force that isn't their own. Their own field magnet-wise is null. It is not North Pole, not South Pole. It is nothing, absolutely null. Superconductors will levitate above magnets. Magnets will levitate above superconductors. The Earth is a magnet. Any superconductor will levitate under the right circumstances. They store energy in a very unique way by means of light waves. If one can imagine the powder as part of a cell and think of it simply as this room. Light is a strange beast. Any amount of light can be put into a space. You can put the light on in this room and we can now see it's light, but we can turn on more lights and add more light. And we can turn on more and throw the dimmer switch up and add more. And there is no limit to the amount of light you can put in the space, and it's just the same with this. It will hold energy in exactly that form. There is absolutely no limit to what you can put into this. A fuel cell made of this that takes up no space at all could take you through a lifetime. So they've discovered that the light wave frequency of this is identical to DNA. It resonates with DNA. It's on the same frequency. It treats cancer simply by correcting it. For once, and at last, here was something that was not anti-cancer. Here was something that was pro-life. Every single scientific discovery has an upside and a downside, and it depends how we treat it. When they first made the spark and created fire, they knew then that we could cook food. They knew then that we could keep ourselves warm. They also knew how to burn down their neighbour's house. So there's always an upside and a downside. The positive generally seems to prevail. I think the human race is generally pretty clever when it comes to keeping things in order. So I think that the prospect of body roaming wardens and the ultimate defeat of motor neurons disease, muscular dystrophy, AIDS, cancer, multiple sclerosis and all those sort of things is a bit better news than worrying about the possibility of being overtaken by robots.